In this video, we're going to look at some of the area and volume questions that have come up recently. The key to these is figure out what shape they're looking at, cylinder, cylinder, and then go to the formula booklet if you don't know the formulas off by heart to find out the key word in the question, and it's highlighted volume. So the volume of a cylinder, written as capital V small c, is pi r squared h. The only unknowns here are your r and your h. Pi is a number. The answer is in terms of pi. It has pi in it. So we need to find out what r is. Always write it down, and what h is, and then just fill it into the formula. So we have internal diameter 6. And you can see here it's given all the way across. So r is half the diameter, and height 20. So pi by r squared by h. 9 times 20 is 180. So we have 180 pi centimeters cubed. And that is proven what we have been asked to prove, quadrat demonstrandum. Dara's inflating a balloon. So every pump, it's going to fill up 180 pi centimeters cubed for every pump. When fully inflated, the balloon has a radius of 15. Find the volume of Dara's balloon. So we need to know the formula for volume of a sphere. I'm not expecting all of you to know it, so go to your formula booklet. So I'll just show you what it looks like when you go to the formula booklet. This is the page you should see. A sphere, and we've got area of a sphere. There's only radius involved, 5 pi r squared. The volume, 4/3 pi r cubed. 4/3 pi r cubed, and r here we are told is 15. So 4/3, just come to the side, by 15 cubed by pi, and we're in centimeters cubed in terms of pi, so we need pi in the answer. So 4 by 15 cubed divided by 3. 4500 pi cm cubed is what my calculator has given me. 4500, I'll just check it again. 4500. So just bringing the information down, we're told Dara pumps the pump once every second. So one pump, we saw part A, 180 pi goes in, centimeters cubed. How many seconds to fully inflate his balloon? Well, the total volume, 4500. The pi's will cancel now, divided by 180 pi. So we don't need the pi's now, the zeros cancel. So 450 divided by 18 is how many seconds it will take. That gives 2.5. Let me just 450. Sorry, 25. 450 divided by 18. 25 seconds. I'm getting on my calculator, just double and triple checking. 25 seconds to inflate the balloon. Gustav is inflating a bigger balloon in the shape of a sphere. He also pumps once every second, and his balloon is fully inflated after 50 seconds. Find the radius of Gustav's balloon. Okay, well, let's take the 50 seconds and multiply it by how much air goes in every time, 180 pi. So 50 by 180 is 9,000 pi cm cubed, twice the other one. Now this is equal to 4/3 pi r cubed. So is the radius just double? Let's have a look. So if we multiply by 3, we cancel the pi's initially. We can multiply by 3 and divide by 4, so we get 27,000. 9,000 divided by 3 and bring over the 4 is equal to r cubed. So this can go directly into the calculator, the cube root of 27,000 over 4. And we're asked correct the one decimal place, so it doesn't work out as just double the other one. It's giving me 18.89, so 18.9 centimeters when it's fully inflated. So a question, not necessarily, it's area. I suppose area of a circle is involved here. 25 pi centimeters squared is the area of the circle. It's highlighted in bold. And we have this diameter. Now, some of the knowledge from the old junior cert course, the diameter, if you have any arc standing on that diameter, the angle here is 180. The angle here is half it, which is 90. So we can put in a 90-degree angle there. Similarly, any angle standing on an arc, it doesn't have to be the diameter that goes through the center. this angle will be twice this angle. It's one of the old theorems. So let's take the area of a circle. Pi r squared is equal to 25 pi centimeters squared. So I'll just leave out the centimeter squared for a sec. Cancel my pi's. So r is equal to 5 here. R squared is 25. So r is equal to 5. So I have 5, 5. So I have a right angle triangle where the angle opposite the right angle is 10, or the size of the side opposite the right angle is 10. One of the straight sides is 8. So this is going to give me the square root of 10 squared minus 8 squared for the third side, your knowledge of Pythagoras, and that will be 6. So you can see it's just double the 3, 4, 5 triangle. 5, 3, 4. We can double it up, it'll still be right angled. So the size of the angle, the smallest angle will be opposite the smallest size, so it'll be this one here. So we can use SOHCAHTOA, so we can say that any of them, we have all three sides. So let's say the cos of this, the tan of this angle is opposite the tan of, let me call it the angle, we have ABC, I'll call it the angle X. The tan of the angle X is equal to opposite over adjacent, and the inverse tan of 6 over 8 or 3 over 4, doesn't matter which ratio you use, will give me the size of the angle to be 36.87, corrected 2 decimal places, so we'll call it 37 degrees for the smallest angle in this triangle. So we're seeing similarities already. We've got a cylinder again here. Pi r squared h is the volume. We've seen that already. Let's call it the volume of the sea. Pi r squared h. We want our answer to 2 decimals, so we're not leaving it in terms of pi, and we're given the radius. So pi by 3.6, which is the radius, to be squared. Height of 10 by 10 is just calculator use. Type this into your calculator, write it out to 3 decimals, and then simplify it to 2. And it's 407.150, so actually it gives us corrected 2 decimal places, and that would be cm cubed for volume. 24 of these cans are packed into a closed rectangular box, and they're arranged as follows. Okay, well, let's have a look. Height, length, and width. The length is given to us. Where does this 28.8 come from? How high are they? Well, the height of them is the height of 2 cylinders, so h is equal to 2 by 10. So the height is 20. The width, if you imagine 2 radiuses in the first one, 2, 2, 2. The width is, or the length is 8 radiuses. Just double check that. 8 by 3.6, 24 and 4.8 is 28.8. So yes, of course they're correct. And then the width, what have we got going on with the width? The width is this way, 6 radiuses, 2, 2 and 2 all the way across. So 6 by 3.6 is 18, and 3.6, which is 21.6 for the width. The volume of the box is going to be the 3 multiplied together, 20 by 28.8 by 21.6. Just type that into your calculator, 20 by 28.8. Double check your answer each time when you use the calculator. This is giving me 12441.6, 12441.6, and that's centimeters cubed. And the percentage of the volume of the box that's taken up by the 24 cans. Okay, so we got the volume of 1 can. We got 407.15. We're told that there are, what do we say there was? 24 cans. We're told that 24. So 407.15 by 24 is what the cans take up. 407.15 by 24 should be close to the volume of the box, but not too big. 977, 1.6. So there's a lot of empty space. That's the volume in cm cubed of the cans. 977, 1.6. 977, 1.6 out of a total of 12,441.6, and times 100 would give the percentage that's taken up by the cans. Just make sure it's not the spare space. They can ask that as well. It is taken up by the cans. So type that into your calculator, and you will get an answer of looks like 3/4, just over 78. Correct the 1 decimal place, 78.539. And correct the 1 dp. Don't forget to round off, 78.5%. Taken up by the cans in this box. The last part of this question you have to think about, there are a number of different ways of arranging 24 cans so they can be packed into a rectangular box. Let me attempt to draw one of these cans. There's one of them, they could just be 24 wide, that might be the easiest thing to do here. Although it's not a real accurate box, but what if it was just 1 by 24? That is a rectangular box, so that might be the easiest one to do here. So 24 wide is 24 radiuses by 2, so 24 by 2 will be 48 radiuses wide. So let's multiply that by 48, and then the height would just be the height of the box, which was 10. So the length will be 2 radiuses wide, or the width will be 2 radiuses wide, and the length will be 48 radiuses wide. So let's see what we got for those. The radius was 3.6 and the height was 10. So the width is 2 by 3.6, 7.2, and 48 by 3.6 is going to be the width of this ridiculous box. 48 by 3.6 is going to be 172.8. Bit of an odd shaped box, but we're in an exam, we want to do what's easy. So I think this is the easiest one to look at. In this question, told the diameter of a circle, we're asked to work out the circumference. The circumference of a circle is 2 pi r, 1 decimal place in the answer. If the diameter is 8, the radius is 4. So 2 by pi by 4 is what you're going to type into your calculator, 8 by pi. And there is the pi symbol on the calculator. They differ, so find out where yours is. 25.132. And to 1 decimal place, 25.1 centimeters. And then underneath that, we have a rubber track for a toy digger, and it goes around 4 circular wheels of diameter 8. So it's the same circle. Calculate the length of the rubber track that goes around the 4 wheels. I'm going to draw a line down here. So to the left of that is half a circle. And I'm going to draw a line down here, and to the right of that is half a circle. So those two added together are 25.1. It's the same circle. And then what's left in between? Well, 4 here, 8, 8, and 4. So that's going to be 4, 8, 8, and 4, which is 3/8, which will be 24. 16 and 8, just check. So 49.1 is the length of the rubber track. That's what they're looking for you to do here. Correct the 1 decimal place we have. So I should really have put a different color on just to make it a bit clearer. This up here is 24, but then so is this one down here, isn't it? So I have to add 48, so I'm going to add another 24 on to get 73.1 centimeters. 48 and 25.1. Part C, every time the wheel turns fully, the digger travels a distance equal to 1 wheel circumference. Well, that's 25.1. How many times will each wheel turn fully when the digger travels a distance equal to the length of its rubber track? Well, that will be 73. It will be 73.1 divided by the 25.1. We ask corrected decimals or anything here? No, just 73.1 divided by 25.1. Nearly 3 times, 2.924 times. So nearly 3 times for how many times each wheel will turn fully. And this one we're going back to the volume of a box. What's the volume of this box? 5 by 14 by 24. And that's going to be 1680 cm cubed for the volume of this box. 36 of them are placed in a packet that's covered in 1 centimeter thick. 36 is packed together, and a cover that's 1 centimeter thick is put around the outside of the 36 boxes as shown. Work out the dimensions of this cover in centimeters. Okay, so if we look at the width, we have 3 across, the width is 42. The length is 3 back, 3 of these, so 3 by 24 is going to be 60 and 12, 72. And then the height is 4 high, so 4 of these guys, so 20 you can see there, 20. And we have a 1 above it here and a 1 below it, so 22 for the height. Try and do a 3-dimensional box. 22 high, and then it's going to be 2 extra long, the 1 here and the 1 here. So it's going to be 74 along this way, 74. And then the width is going to be 14 plus the 1 and the 1. Sorry, the 42 plus the 1 and the 1, so that will be 44. In part C, we're told the cover that's put around the 36 boxes is made of plastic, and we have to work out the volume of plastic. So what have we got here? We have the 30, how many boxes? 36, wasn't it? 36 boxes at 1680. So 36 boxes at 1680 is the volume inside the plastic. 36 by 1680. So 60,480. That's what the boxes are. Without the boxes, just the total volume is the 22 by 74 by 44 from above. 22 by 74 by 44, and that's equal to 71,632. So the volume of the plastic must be the difference between these two numbers. 71,632 minus 60,480 gives 11,152, and the volume is in centimeters cubed for the volume of the plastic.